Hello JAMBites, welcome to another edition of our Chemistry JAMB Expo. And in this video today, we are going to talk about a very useful aspect as far as JAMB Chemistry is concerned. And if you are able to score high in your JAMB exam as a chemistry student or someone who is going to write chemistry in their JAMB exam, then this video is perfectly for you. Because in this video today, we are going to talk about the industrial and the laboratory preparation of some substances. How do we prepare what? Oxygen. The oxygen you get in the hospital, how is it prepared? Is it that they go and trap just the oxygen in they trap the oxygen and they take it to the hospital? No, this oxygen is what being prepared what? Industrially. And also this oxygen can be prepared in the laboratory, and that is what I'm going to share with you today. My name is Basi Ejoba. I'm a 400 level student in the University of Calabar studying medical laboratory science. And in my channel, I help students level up their academic game. I also share helpful tips on the channel focusing on personal development. So if you love content like this, please don't forget to hit on the red subscribe button so you can continue getting updates anytime I drop videos like this, and so that you can help me grow. And just like I've said today, we are going to talk about the industrial and laboratory preparation of some substances. So first of all, we are going to talk about the first substance which is in our list, or the first element, which is known as what? Hydrogen. Which is what? The industrial laboratory preparation of hydrogen. This is what? Hydrogen on the board. With what? H1, 2. So how is hydrogen prepared? First, we are going to talk about the laboratory preparation first before the what? Industrial what? Preparation. So how is hydrogen prepared in the what? Laboratory? Hydrogen is simply prepared when zinc reacts with dilute hydrochloric acid. Zinc as an element reacting with a compound that is known as what? Hydrochloric acid. But at this particular time, not a concentrated hydrochloric acid, rather a dilute hydrochloric acid. As you can see here, let me give you the reaction of the laboratory preparation of hydrogen. So what we have is zinc. This is zinc as an element. Zinc plus what? Hydrochloric what? Acid. Now, zinc reacting with hydrochloric acid will give you a forward reaction. This is zinc reacting with hydrochloric acid, giving you a forward reaction of what? Zinc chloride. Zinc chloride, give you a forward reaction of what? Zinc chloride plus what? Hydrogen what? Gas. So, zinc reacting with what? Hydrochloric acid, giving you a forward reaction of what? Zinc chloride plus what? Hydrogen what? Gas. But when you check this reaction, you get to find out that this reaction is not balanced, because as you can see here, we are having what? 1 mole of what? Zinc plus what? 1 mole of what? Hydrogen plus 1 mole of what? Chlorine. Give you a forward reaction of 1 mole of zinc, 2 mole of chlorine plus 2 mole of hydrogen gas. So to simply balance this reaction, we are going to put 2 here. We are going to put 2 here, making it our zinc, our chlorine here is balanced, and our hydrogen gas here is balanced. So that is how we what? Prepare what? Hydrogen in the what? Laboratory. So let's talk about the industrial preparation of what? Hydrogen. So preparing hydrogen in the industry is simply steam reforming of what? Methane. When you what? Steam what? Methane. So to get this, don't forget that methane is a member of the family of alkanes. The methane is a member of the family of alkanes, and is the what? First what? Member. And methane is a natural what? Gas. So this is simply steaming of what? Natural what? Gas. So how do we get this? We say what? This is for the laboratory preparation. So for the industrial preparation, we say what? Industrial preparation. For the industrial what? Preparation. So for the industrial preparation, we have what? Methane, which is what? CH4 plus what? Water, which is what? H2O, giving you a forward reaction of what? Carbon monoxide plus what? Hydrogen gas. Okay, sorry, giving you a forward reaction of carbon monoxide plus what? Hydrogen what? Gas. At this particular time, you heat this, you use a catalyst. A catalyst is what? Being used at a very high what? Temperature. So you can simply say catalyst. You can simply say what? You can say what? Catalyst. At what? High temperature. So you say what? Catalyst at a very high what? Temperature. But if you check this reaction also, this reaction is not what? Balanced. When you check this reaction is not what? Balanced. So to make this reaction balanced, as you can see here, we have what? 4 moles of what? Hydrogen here and 2 moles of hydrogen here, making a total of what? 6 moles. And here we are just having what? 2 moles of what? Hydrogen. To make this balance, we simply add what? 3 here, making it what? 6 moles of what? Hydrogen, and it is what? Balanced. So this is how what? We prepare what? Hydrogen. Please take note. Hydrogen is first prepared in what? Laboratory by heating or reacting zinc with what? Dilute hydrochloric acid, as you can see on the board. And for the industrial preparation, we have steam reforming with what? Methane, giving a forward reaction of what? Carbon monoxide plus what? Water plus what? Hydrogen what? Gas. So that is for what? Hydrogen. So let's talk about the next one, which is what? Oxygen. How is oxygen prepared? First in the laboratory and secondly in the what? Industry. So for oxygen, which is what? O2. Oxygen, which is what? O2. For the laboratory preparation of what? Oxygen, we have what? The decomposition of what? Hydrogen what? Peroxide using what? Manganese what? Oxide as what? A catalyst. Decomposition of what? Hydrogen what? Peroxide using what? Manganese as what? A catalyst. So to write it down, this is what we are going to get. Remember, okay, let me show you how we get it. When I say decomposition, note that decomposition is a type of what? A chemical reaction. Yes, it's a type of chemical reaction. And decomposition simply means what? The breaking what? Down. So when we say decomposition of hydrogen peroxide, note hydrogen peroxide is what? H2 what? O what? 2. This is what? Hydrogen what? Peroxide. So the breaking down of this hydrogen peroxide, we are going to get water. First of all, we are going to get what? Water and our oxygen what? Gas. So you say what? Hydrogen peroxide giving us what? H2 what? O. I don't think you are seeing it there. So you're giving a forward reaction of what? H2 what? O plus what? Oxygen what? Gas. Plus oxygen, which is what? A gas. So this is what it gives us. Breaking down this what? Hydrogen peroxide giving us what? Water plus what? Oxygen what? Gas. But if you check this reaction also, this reaction is not what? Balanced. Check the reaction here. The reaction is not what? Balanced. Because we are having what? 2 moles of what? Hydrogen here, and we are having 2 moles of hydrogen here. We are having 2 moles of oxygen here. But when it comes here now, we are having 3 moles of what? Oxygen. So to make this balance, to make the both of them balance, how we simply do is to add 2 here, and we also add 2 in our water. Also add 2 in our water. So this is 2. So you have what? Hydrogen peroxide breaking down to give us what? Water plus what? Oxygen what? Gas. For in the industrial what? Preparation of what? Oxygen. For the industrial preparation of what? Oxygen. Industrial preparation of oxygen. For the industrial preparation of oxygen, we have fractional distillation of what? Liquid air. Fractional distillation of what? Liquid what? Air. Note that oxygen is a component of what? Air. And the only way we can separate our oxygen from other components of the air is through what? Using their what? Boiling what? Point. And how we can use a boiling point? Note that the only separation technique that is based on boiling point is what is known as what? The fractional what? Distillation. Oxygen boils at minus 183 degrees C. So we have fractional distillation of air for the industrial preparation of oxygen. Fractional distillation of air. Noting very well that oxygen boils at minus 183 degree what? Celsius. So this is how we can what? Prepare what? Our what? Oxygen, either in the what? Laboratory using what? The breaking down or the decomposition of hydrogen peroxide giving us what? 2 molecules of water and what? Oxygen, what? Gas. And the industrial preparation is simply the what? The fractional distillation of what? Air. Where we have our oxygen boiling at what? 183 what? Minus 183 degrees Celsius. So the next one on the list is carbon dioxide. Carbon dioxide. Please, if you love this video and you want to support this channel, you also want to score high in your JAMB exam, please don't forget to hit on the red subscribe button. Share this video to your friend also, so that the both of you will come here and get value. You will grow, you will pass your JAMB exam, and I also will feel motivated to continue dropping videos like this. So the next one I talked about is what? Carbon dioxide. So for carbon dioxide, we have the laboratory preparation of what? Carbon dioxide. For the laboratory preparation of carbon dioxide, we have the what? Reaction of dilute hydrochloric acid, dilute what? Hydrochloric what? Acid plus what? Calcium what? Carbonate. So reaction of dilute hydrochloric acid with what? Calcium what? Carbonate, which is what? Ca what? CO3, giving us a forward reaction. Giving us what? A forward reaction of what? Giving us a forward reaction of what? Calcium chloride. Calcium chloride plus what? I'm going to extend this thing. Calcium chloride plus water, that is H2O, plus what? Carbon dioxide as a what? Gas. That is giving you out this what? Carbon dioxide as a what? As a what? Gas. So checking out this reaction, you will get to find out that this reaction is not also what? Balanced. When you check this reaction, is not also balanced. For this reaction to be balanced, we simply add 2 in our what? HCl, and we check for others, automatically they are balanced. It is balanced, sorry. If you change the reaction, 2 molecules of hydrogen here and 2 molecules of hydrogen here, our chlorine, which is 2 molecules here now, it's also 2 molecules here, and all of them they are balanced. So this is for the what? For the laboratory preparation of what? Carbon what? Dioxide. And we also have the industrial preparation of carbon dioxide. We also have the industrial preparation. So for the industrial preparation of what? Carbon dioxide, we have from fermentation. Carbon dioxide can be formed in or can be prepared in the industry from fermentation as a byproduct in limestone or cement industry. So for the industrial preparation of this carbon dioxide, it is gotten as a word fermentation. Fermentation of what? Cement or what? Limestone. So that is how we are able to get our what? Carbon dioxide. Carbon dioxide can be gotten as industrial preparation as a fermentation or a byproduct of what? Cement or the limestone what? Industry. So let's talk about the next one, which is very, very important, and that is known as ammonia. Ammonia is very, very important. As far as you are writing JAMB, you will get to see ammonia. If you don't see ammonia, then you are going to see the rest of the substances which I am making in this video. So we have what? Ammonia, which is what? NH3. We have what? Ammonia, which is what? NH3. So for the laboratory preparation of ammonia, we simply have what? Heat ammonium what? Salt with what? Alkali. The heating of what? Ammonium what? Salt, which is what? This is what? Ammonium. That's an ammonium salt with what? An alkali, which is what? CaOH what? Open, close your bracket 2. I don't know whether you can see this. Sincerely pray. Alright, let me see if I can be able to get it here. We have what? NH4Cl plus what? CaOH2. OH what? 2. Giving us a forward reaction. Giving us what? A forward what? Reaction of what? calcium chloride plus what? Water plus our what? Ammonia, which is what? NH3. Ammonia what? As a what? Gas, which will represent what? G. So this is just how the what goes. Balancing up the equation, we simply put our what? 2 here, and we put our 2 here. If you don't know how to balance chemical equation, I will also drop a video on how you can be able to balance up chemical what? Equation. I will drop a video on how you can be able to balance chemical equation. So this is simply the laboratory preparation of what? Ammonia, where you what? Heat what? Ammonium what? Salt. Where you heat what? Yes, you heat ammonium salt with what? An alkali, giving what? Calcium chloride plus what? 2 molecules of what? Water plus what? 2 molecules of what? Ammonia what? Gas. Then for the industrial preparation of ammonia is what is known as the what? Haber process. Haber process. The industrial preparation of ammonia. Right here, industrial prep. We have what is known as what? The Haber, Haber, Haber process. That is for the what? Industrial preparation of what? Ammonia. So the Haber process is simply nitrogen plus what? Hydrogen, giving us what? A forward and a backward reaction. It's a forward and a backward reaction. Giving us a forward and a backward reaction of what? Our ammonia was gas. So if we check this reaction is not actually balanced, but we can balance it by just putting 3 here and by putting what? 2 here. So this is what our ammonia was gas. Now this Haber process occurs with what? A catalyst known as what? Ion. Catalyst. A catalyst known as what? Ion as a catalyst. So it uses what? Ion as a what? Catalyst under high temperature and what? Pressure. For the Haber what? Process. It uses what? Ion as a catalyst under high temperature and what? Pressure. Then for the next one, which is also here, the chlorine. Preparation of what? Chlorine. You have the preparation of chlorine. So chlorine is what? Cl2. Am I correct? So for the preparation of our chlorine, the laboratory preparation of chlorine is simply what? Heating what? Reacting manganese oxide with what? Concentrated hydrochloric what? Acid. So what? Manganese oxide, which is what? MnO2 plus what? Hydrochloric what? Acid. Sorry. With what? Hydrochloric what? Acid. Giving us a forward reaction. Of what? Manganese chloride plus what? Water plus what? Chlorine what? Gas. So we have what? Manganese chloride plus what? H2O plus what? Chlorine what? Gas. As in what? Chlorine gas. As you can see here, manganese plus what? Concentrated hydrochloric acid giving us what? Manganese chloride plus what? Water plus what? Chlorine what? Gas. Balancing this, we simply put in our 2 here in the water molecules and we put 4 in our hydrochloric acid. To check the reaction is what? Balanced. Then for the industrial preparation of chlorine is simply the electrolysis of what? Brine. Industrial preparation. For the industrial preparation, it is simply what? The electrolysis of what? Brine. Electrolysis of what? Brine. And brine is a what? Sodium what? Chloride what? Solution. NaCl what? Solution. So please, it is important that you take note of these key points. It is very, very important that you take note of this key point if you are really looking for WAEC or if you want to really pass your JAMB exam. So for the last one, The last one there is, which is the number 6, and the last important substance that JAMB will bother to ask you questions on is simply what? Sodium hydroxide, NaOH. NaOH. So for the laboratory preparation of what? Sodium hydroxide, it is simply the what? Reaction of what? Sodium metal with what? Water. Reaction of what? Sodium metal with what? Water. But note that this is not commonly what? Done. This laboratory preparation of sodium hydroxide is not what? Commonly what? Done. Therefore, the industrial preparation of what? Sodium hydroxide. Let me search for it. So the industrial preparation of sodium hydroxide is simply the electrolysis of brine also. That's for the industrial preparation. It's simply the electrolysis of what? Brine. But this one now is not the sodium chloride solution. Rather, it is what is known as a chloroalkali what? Processes. The chloroalkali what? Processes for the industrial preparation. For the industrial preparation, we have what is known as what? The what? The chloroalkali. The chloroalkali what? Process. And now the product of this particular reaction, which is the what? Chloroalkali process, can be what? Sodium hydroxide, which is number 1. It can also be what? Chloride or chlorine, and it can also be what? Hydrogen what? Gas. So this is what this is simply the preparation of what? The industrial and laboratory preparation of what? Substances in what? Chemistry. Please take note of this and put them into practice. Read them. If you need the PDF, feel free to chat me up on WhatsApp. I'll be dropping my number in the comment section. And if you also need past questions, and if you're looking for who you want to talk to, I am always free to respond to you. Note that you are very capable of achieving your dream JAMB score. You are capable of scoring up to 250. You are capable of getting 300. You are capable of getting 320. But you can only do this when you give in your effort, determination, and what? Consistency. If you love this video and you wish to score high in your JAMB Chemistry, please don't forget to hit on the red subscribe button and also share this video to your friends so that they can come here and get value. And in turn, I will feel motivated to continue dropping videos like this. And until I see you in my next video, always remember that you're wonderful, always remember that you're unique, and always remember that you're a pace setter. I really love you. Thank you.